to Unit 5, Lesson 5, using graphs to estimate values. So, when we collect data, we plot it on a graph, and the graph can make predictions for the future for us. So, the city has grown over the past few years. The table and graph show us the volume of water each month that a city uses according to the population size. And then it's going to ask us a couple questions at the bottom. It asks us, estimate the monthly water usage for 150,000 people. Well, do I have that number on the bottom? Can I find the number on the bottom?
Yep.
Yes, good. So it's not beyond my graph. It's within my graph. So if I go halfway in between these guys, he'd be about right there. Okay? So that's my 150 million people. So if I want to find out and estimate how much water it used, the strategy is I need to go up to the line from that point and then go left to the other side. So how much do you think, I'll draw very straight, but how much do you think they used for 150,000? Sure, give it a try. Well, halfway between, this line right here is 1250. Right, and if we want to say approximately or around, we use squiggle marks. So we say, well, it's going to be around 1,100, sure, 1,100 milliliters of water is going to be used. Yep.
Around 1,150.
Sure, around 1,150, sure, no problem. The next one, yep. Oh, right, you're right. They're megaliters. Thank you. Which means we actually times the values by 1,000. Okay, here we go. If we are here, we've got 1,400. 1,400. What would I do there? Is that a number on the bottom or a number on the side? The number on the vertical side, the y values. So put the number over here. I got to find that number. About 1,400. Well, he's going to be just under 1,500. And I'm going to do the exact same thing. I'm going to bring my number or my line right across till I hit the graph, and then I take it straight down. And that tells me my x value. So it didn't quite hit 200,000. What would be a good estimate for that? Around what? And that's for this question. What do you think it would be? It's not quite 200,000. We're about right there. And if 150 is there, where would you think it might be at? Good, very good guess. Around 180,000. We might even say 185,000, 175,000 in there somewhere. All right. Now it says predict the usage of water for this many people, 250,000 people. Well, how can I predict that if my graph doesn't go that far?
Find the pattern.
Find the pattern, absolutely. So what am I going to do that?
See it?
Okay. Anybody else? Not sure? Okay. What we do is we extend our graph. It's called extending your graph, extrapolating. So I'm going to extend the bottom. And if I know this many spaces is 100,000, so I'll make that many spaces is 100,000. So that will be 300,000. In between that, it's going to be 250, correct? 250,000. So I need to extend my graph up this far. And then I need to extend the red line. I need to extend my red line this far. It's going to hit my line, which means I'm going to have to take it right to the top of this line. It's going to go right to the top. So where do you think that ended up? How many notches is 500? 2 notches is 500. So that's 2 notches above 1,500. So where did it get up?
1,000.
Sure, 1875 is fine. You could have also used 2,000. That is a precise number?
That's the actual.
Well, it's not. It is a linear relation, so you have to find the pattern of what's going on here. We're just estimating and predicting. We don't need to make exact values, okay? If we did take an exact value, it would be between 1750 and 1850 is where it would be. Okay, around in there. Any questions? Okay, do you see how to find data in a graph? We're going to do that a few times. But we need to know what it's called. It's called interpolation and extrapolation. Well, what is interpolation? That is finding information. So we're going to find information inside or within the graph boundaries. So anything inside the graph where I just take the number up or to the side and down, that's information inside the graph. I can find that easily. But then when they've got information outside the graph, I need to extend my graph. That's where we use extrapolation. Okay? So extrapolation is find information outside or beyond the graph boundaries. Well, how do we do it then? How do we actually do it? We need to extend our graph. So we need to use a straight edge. And almost everything has a straight edge. Your phone does, your calculators do. You have a little ruler, it works perfect. So you use a straight edge. If you want, you can call it a ruler. Use a straight edge to extend the graph. You're going to extend it to the right and up. To the right and up. You're going to extend it to the right and you're going to extend it up. Then you do the exact same things. Find the information, you carry it up to the line and across, or you go across and down depending on which information you're given. So, okay, two different lines I've drawn for you. Doesn't matter if they go up or down, you do the exact same thing. If I said this is 20, let's say this is 60, and I said I wanted you to find a value on the bottom, let's say the bottom is time in minutes, and this might be height. If I said find the time in minutes at 10 minutes, can I do that on that graph? Absolutely. I would find 10 minutes on the bottom. So 10 minutes equals what height? Absolutely. Now how did you figure 30?
It's the middle of 65 by 2.
Okay, 60 divided by 2. Why did you divide it by 2 though?
Because the 20 was divided by 2.
Beautiful. Absolute perfect answer. 10 is halfway between my 20 and my 0. So your answer should be halfway between your 30, or sorry, your 60 and your 0. So if I go up and come across, I should end up at 30. I just don't draw very well freehand. But you should end up at 30. So I would say, okay, well that's going to be at 30 meters for height. I had height in meters. Okay? Now, if we've got a graph, and I say to you, this graph right here is, let's say, I don't know, that's going to be 100. And let's say this up here goes to 50. And again, this is going to be height. And this might be distance. I don't know. The distance of a rock traveling. I don't know what it is. I'm just coming up with something off the top of my head. But if I said to you, a distance of 200, what would be the height be? Can I find 200 on this graph? No, you can't. Well, in this instance, we would multiply it by 2. But what if I said 120, 120. Well, we don't see 120 here. So what we would do is we would just make our notches. Halfway is about that far. You seriously take your fingers or you take a ruler and estimate how far that is, and you extend your graph and make the notch. Okay, well that's maybe about 150. You take a straight edge and you extend the actual graph so it's going on the same slope. You extend the top part. And then now you carry your line up. So I'm going to go up and across. Okay? And you estimate values that way. That's extrapolation beyond the graph. So you have to extend the graph. Yes? Right. You're absolutely right. You can't always just cut it in half. This strategy of just cutting it in half doesn't always work. In this situation specifically, it did work, but it's not always going to work. And usually 80% of the time it doesn't work. Okay, because linear relations don't always go up and down by the same amount, do they? We found in our other linear relation tables that when we've got a table of values, usually x goes up by 1, 2, 3, 4, and y is where we get our pattern. It goes up by varied amounts. It might be adding 3 every time. It could subtract 4 every time. It's going to vary depending on what this is. So you can't just half it to find the other one, okay? Because it will be a variable amount. Okay? All right, let's move to the next part. Here's an example. Student earnings. Says she's earning money. How many hours she works and money earned. Okay, hours worked and money's earned. Says how much will the student earn? So how much money? I'm looking for a y number. How much money? How do I know it's y? Because it's on this vertical part. Okay, the vertical part is always y. So it's asking me how much money, it's a y value, will the student earn if they work this many hours or this many hours, so 3 or 7. So the 3 is within my graph. I find 3, I go up, and I go across, and I estimate. So about $7.50, good. $7.50, around that. Now, the next one, 7 hours. Is 7 hours within my graph boundaries? Yes, it is. So you find the 7, go up again, and go left. So what would 7 hours be around? Sure, $17.50 works nice. Now we're going to find the next ones. The next ones say how many hours. They're asking for the hours. They're asking for an X number. And they're giving us the Y numbers. They're giving us the money. They're saying, okay, $22 and $8. Okay, is $22 within my graph boundary?
I found it just.
It is just within. You could say just within. So you can put 22 right here, and it could be, oh, well, it's not quite just within. You have to extend a little bit. So you should get just over 8, maybe 9 hours. Okay, 8.5 hours, 9 hours. You do have to extend it. So you can between 8 and 9 hours. Well, what about $8? We're going to make $8. Do I have to extend the graph for that one? No. That's okay. So $8. I'm going to come over here. I'm going to find 8. It's closer to 10. And I'm going to draw my line over, and I'm going to go down.
3.5. I mean 3.25.
Well, you could go 350 because it's halfway between them. If that's 3 right there, it's halfway between 3 and 4, right? So it will be about 350. So 3.5 hours. So 3.5. We're talking hours, not money. So it's going to be 3.5 hours. Okay, is that clear on how to do that?
Yeah.
What if I said to you, how many hours do you have to work to make $30?
Ooh.
To make $30. How many hours? What do I have to do there? Extend the graph. Good. So I'm going to put 30 hours up here. And if I see the space, I've got this much space between for 5. So I'm going to put that much space here before I put a 30. And I'm going to extend him across. Well, if I extend across, this guy's got to extend as well. He's still not quite there. And then I'm going to come down. Okay? So you're extending graphs. Yes, sir. 12 hours? Excellent. 12 hours. Beautiful. All right. Any questions on interpolation and extrapolation? Try the last one yourself, please. Try this last question yourself. Push pause now, play when you're ready. All right, you had a couple minutes to work on this question. We found that 100 degrees, most people decided that it's around 80 minutes it takes there. Remember, we don't know how much heat's being applied, so we can't just say, okay, well, that's a wrong answer. It depends on the amount of heat being applied. What do you have for an answer for 85 degrees? A couple answers here. Let's start in the middle. Okay, around 60, sure? 61? 65? It is around 65. So you could say between 60 to 65 as well. Between 60 to 65 minutes, sure. All right. Well, this one down here has 60 minutes. So if we said this is between 60 and 65, what should the degree be then around? Around 80. So we should say around 80 degrees. Is that a consensus of the group?
Yes.
Okay. 75 minutes then. What would that become? 75 minutes. Sorry? Oh no, way more than that, dude.
95 degrees Celsius.
It's exactly 95.
I was gonna say
It's
between 95.
95 degrees. We can say around. You might have said 92 degrees. You might have said 98 degrees.
Yeah,
Okay, 100 degrees is very close. Because these two are very close, right? Those two are very close. Any questions on interpolating or extrapolating data? No? Excellent. Okay, this concludes lesson 5.5, graphs to estimate values.